Okay, well, these downloads, I'll just tell you a little bit about what the presentation is about. I was asked to give you a brief introduction to the internet, a little bit of the history, and a little bit of a brief introduction to the main protocols, and a little bit about the infrastructure here in New Zealand. My name is Jairo Gutierrez. I'm with AUT University. And the first part that I have in my presentation was about the origins of the internet. And a lot of people think that the internet came out of just cooperation and collaboration from scientists and people wanting to share resources. And it looks almost like almost a byproduct of the hippie culture of the 60s, but it wasn't really like that. The internet was a product of military investment on research. And the root of all of that is on the SAGE system in the States, the semi-automatic ground environment that was deployed in the 50s to be able to detect missiles and coming into the United States. So they set up a whole network of monitor centers to kind of blanket the states with these monitors and to be able to coordinate in an automatic way the detection of these missiles. And a lot of the technologies that came out of that effort put down the building blocks of the internet. In fact, the building blocks of what became the ARPANET, which was the Advanced Research Projects Agency of the Department of Defense. The ARPANET came about in the 60s. And when we look at the history of the ARPANET, a lot of the things that came out of the SAGE environment, memory work, software, pooling of resources, interfaces with computers, the light paint, individual terminals, the interconnection of the nodes. All of those ideas fed into a lot of research that was done with ARPANET. Now let me see if I can just, this is really a pity that I can, because I have a lot of cool photos to show you. Okay, let's see. It seems that it's doing something now. Yeah, let's save it. Okay, it seems that we're going to have video in a minute. If we find where it's saving it, because it didn't ask me. Okay. Let's see. Downloads, that will be my guess. Yep. Okay, here we go. As soon as this 0K base changes, then we have something there. Okay, here we go. Sorry about that, guys. It's my apologies. So, we see that now? Okay. All right, so let's, let me see if this works. Okay. Okay. All right, so that's what I had. This is the kind of nightmare scenario that they had in mind when they tried to design Sage. And that was the military wing of Sage. This was the idea, a detection of one of those unfriendly planes, then communication to the nearest control center, and then send a missile to meet them. Right? A lot of work spread out into, I guess, the military industrial complex in the States. A lot of the initial companies in computer were involved, IBM, Xerox, which became Unisys, and a lot of labs, also research labs, and they all did the little bit to contribute to this Sage environment. Some of the facilities in here, some of the control centers, they ended up having 24 centers, 100 operators around the clock. These are some of the radars and monitors that they have. Look at the workstation, right? I mean, we laugh now, but a lot of pioneering features were introduced there. This is one guy with one of the very first light pens. Look at how bulky that light pen is. Some of the centers here, it looks like an old air traffic controller setup. Looking at the map, look at all these things that came out of that research. Time sharing, interactive displays, networking, buffer input and output devices. Quite a lot of money went into this. Quite a lot of money. And they had it for about 20 years, and then, Reagan, the Cold War was over, and this thing was decommissioned. On record, as far as we know, it never detected an unfriendly airplane. Actually, that happened in 2001. Okay, some of the things that came out of here as well, the ballistic early warning system. You see in there let me see if I can get the pointer, the worldwide missile control system. And even some of the acronyms already, we have some precedents with some of these efforts. Some of the early mini computers, not mainframes, but mini computers like the PDP series came out of research and development grants out of this effort. This is how, just after the war, people imagine what a kind of a home computer might look like. I quite like the wheel. I don't know, that might be the cursor, but I think that's very cool. Yeah? Okay. Thank you. All right, so late 50s, Sage, and trying to go quick now. In the 60s, ARPANET, there were originally just 4 nodes, USLA, the famous Professor Kleinrock there, UCSB, and a couple of other nodes. Then it grew very slowly and until really we got to the World Wide Web. TCP/IP developed in the early 70s. Up until the early 90s, it was still controlled by the National Science Foundation, and then in the 90s, basically, we had the explosion of the internet. I mean, if you look at this evolution here, and more importantly, the hockey stick figure here, nothing much happened for 10 years, 20 years, even if we count the early 70s as a beginning. And then the World Wide Web and the whole thing took off. Okay, I have a link here to more updated information. I'm just going to skip that, but at the moment, there are counted as users in the internet, close to 3 billion users in the world. That's nearly half of the population classified as internet users. So that's how much this thing has grown. A little bit of the split, as you can see, the increasing importance of Asia, with getting close to 50%. I will not be surprised if next year it's already half of the users in the world. A little bit about the evolution of the internet, going from kind of a connectivity sort of commodity service to something a little bit more clever, perhaps with services, although this has been debated for a long time. Business requirements always the driver of this thing, trying to do more with less, trying to minimize the wide area network links, which are really the expensive ones. A little bit about a network for everything these days, voice and data as the big traffic sources, but really the tendency, the trend to mix these two and get into what is called in the industry as convergence, having voice and data all over the same network. That's the reason you don't have telephone divisions in any organization these days. It's all the network. It's only one network. I guess for a lot of these things, you can just throw more money, more bandwidth, or try to do things in a smarter way. This is obviously a simplification. It is easy to throw money on the bits of the network that you own, in your campus, in your organization, in your building. It's a lot more difficult to do that on the bits that you don't own, the ones that you have to hire from other people. And that's expensive, and that's where you actually have to try to do things a little bit, in a smarter way. Just an idea, again, this is very, very simplified, of what the internet looks like. End users around here, they will connect to an internet service provider at a particular point of presence, and there will be several of these ISPs connecting to bigger carriers, and there is whole bunch of ways that they are connected. Some of them are peering points where basically they agree to exchange traffic. And you basically have the routers as the basic devices. And the key to this resilience of the internet is the idea that you have multiple paths. You have multiple ways to get to a destination. And if a particular link fails, there will be always ways to get to where you want to go through other paths. A little bit more about that. The idea here that there are different tiers of providers, of network providers. Some of them at the backbone carry quite a lot of traffic, and there are probably 6-8 companies in the world that are the huge backbone carriers, and they form that tier 1, and then you start going down the food chain until you get to your local internet service provider. I'm going to go very quickly. I'm concerned about kids' time. A little bit about protocols. Protocols is just the common definition of the word. How do we interact? If the Queen comes to visit New Zealand, there is a protocol that says that I cannot run and give her a hug. That's not the done thing. Here in communications, it's similar. What is a protocol? Okay, if I want to talk to another computer, what do I do? How do I say, hello, I want to talk to you? So there must be some rules as to how do I declare my intention that I want to talk to you? How do you say, okay, I want to talk to you, and then carry on? So there are basic protocols. You look at layers where you say, okay, you have some infrastructure, some technology where that I'm using to connect my devices, and the key protocols in here are the one that takes a message and break it into pieces and puts an address on that piece so that it can get to a destination, and another one that basically controls an end-to-end session, not between hosts, but between processes in that particular host. A process is a sort of a program in a host, a computer. So you have them working in tandem to provide a communication link. And with that sort of protocol, you have every single type of communication these days. You know, you go to your house and you will have your kid playing with their Nintendo. You will have a Nintendo DS, and that has a wireless connection. And you have your Wii, that also has a wireless connection. You have your tablet, you have your PC, you have your phone, everything working on the same network. This is, again, the protocols. These are utilities that are used by the programs on top of the stack. These are the top two protocols that I mentioned before, and then some sort of network. The beauty of TCP/IP was that TCP/IP could basically run on anything. You know, it was agnostic in terms of what the network was. In fact, in early Internet Engineering Task Force meetings, they have these T-shirts where they say IP on everything, you know, which has a sort of double meaning. But okay, I'm going to skip this really, how the data is encapsulated. I'm just going to go to talk about this idea of the DP. That's a very old-fashioned word, data processing. You know, that harks back to the 60s. And the point here is that we had gone from one side to the other side of the pendulum, you know, from centralized systems that you know, bureau type of systems that you hire to run your accounts, through the whole gamut of networks and so on. And now we're back to that sort of figure of, you know, somebody somewhere running things for me. A little bit about the infrastructure here in New Zealand. Kind of ultra-fast broadband world, you have a big player, Chorus, used to be Telecom. And then in the UFB world, things are going to change. I mean, Chorus will still have a pretty dominant role, as we can see by the look of things. But we're going to have many other players, and you know, there is a lot of interesting stuff happening in this space. A little bit about how Chorus provides services to other companies, the so-called retail service providers. One of them might be your ISP, right? For instance, Orcon. Orcon might be one of these retail service providers connected to the Chorus infrastructure. Sorry, that will be more likely on the new UFB setup. Optical exchanges, that means fiber gets very close to your home. And then from that exchange to the houses that are very close, you'll have that connection, and through the retail service provider who will hook up to one of these big UFB infrastructure players. So I'm sorry I have to rush at the end, but I stop it there and have time for some questions, and then we go with the second. Any questions? Stay here, and then if we have questions at the end, we might just combine the questions for the both of us. Thank you.
Hello? Hello. Gosh, it's got to work from really close. Is that working okay? Okay, sorry. And I'll just figure out where my presentation's got to. Okay, now this part of the session is on internet governance. So this is a non-technical presentation, and it's more looking at who owns or who controls the internet and why. Or to put it another way, how we got into this mess. And I see Jeff Houston's here in the corner. So Jeff, some of the dates might not be absolutely accurate, and I know you're a stickler. But please don't, yeah. I think this is more about the formula of where we've got to rather than accuracy of data, because as we know, not all the statistics on the internet are always 100% accurate. Okay, by way of introduction, my name's Keith Davidson. I'm the International Director of Internet NZ. I also do a whole host of tasks internationally as a result. I'm the Vice Chair of the Asia Pacific Top Level Domain Association. I become an ISOC Director from August. I'm the Vice Chair of the Country Code Name Support Organisation in ICANN. I chair three delegations of CCTLD's working group. I convened the Pacific Internet Partnership a couple of years ago and have been participating in the internet governance arena for some years. And I used to own and operate a little ISP in New Zealand, so I guess in summary I know a little bit about this space, but not a lot. Today I'm going to talk about the relevant parts of history that contribute to internet governance, who the current actors are, which I also term as alphabet soup. Thirdly, the transition or collision or convergence between the players, and then a brief summary if I can. Okay, so in the beginning, telegraph was invented somewhere between 1804 and 1837. It wasn't a sudden invention, but it came about as a result of a number of initiatives, culminating in Morse code and the actual zeros and ones or blips across an electronic transfer, an electronic wire. So enabled an end-to-end process of transmission of data. So if you like, that was the very beginning of the internet, if you like. It was the transmission of data. The telephone was invented not in one hit either, but somewhere between 1844 and 1876 with different pieces of it coming about. But there was perceived in the early 1860s a need to regulate and control the protocols of telephony. So the International Telecommunications Union was born in 1865 with its mission to enable the growth and sustained development of telecommunications and information networks and facilitate universal access so people everywhere can participate in and benefit from the emerging information society. That's a much more modern view, but essentially they were created to look after telephony, what we call POTS, the plain old telephone system from old, and the ITU, it still exists today. It's a treaty organisation under the auspices of the United Nations. And you'd have to say that in terms of your ability to make a telephone call end-to-end across the planet, generally they've done a pretty good job of enabling telephony to be seamless in that regard. Okay, the internet's beginnings. We heard already that the 1950 space race led to the DARPA, the concept, and 1962 the vision was to establish a galactic network, and ARPANET being the outcome, an experimental network established in 1969. So looking at sort of the milestones, if you like, in terms of what's happened on the internet, I'm not going to go through these one by one, but probably the critical ones. 1969 was standards were established using what's known as the RFC process. Now this was really interesting. As we were hearing earlier, the internet was being developed as a military tool. This was part of the Star Wars program, and yet the standards were being developed on this new process called a request for comment. So RFC 1 was produced by Steve Crocker in 1969, and this was, in talking to the likes of Steve Crocker, it was because it was a military network and a military thing that they wanted to avoid the need to go through the production of field manuals, which would have said, if you want to use this network, you must do it like this. You can't do it any other way. That's the prescribed military methodology by field manual. So what Steve Crocker and Bob Bob Kahn and Vint Cerf and others tried to do was to enable this network to grow harmoniously by publishing RFCs which explained the protocols and the behaviours anticipated on the internet rather than saying this is the way you must behave. So it was kind of a useful change in mindset of nobody owning and everybody broadly abiding by these rules and anyone being able to develop a protocol or a process for the internet via an RFC. And that still exists today. 1973, to me, was the first killer application for the internet, FTP, the file transfer protocol, which enabled you to get a file from one place to another from different platforms, different computers, but reassembling the packets in some sensible order at the other end. 1983 was the second sort of killer app, which to me, which was email. And email wasn't suddenly invented in 1983, but suddenly there were a number of users and it became kind of usable. I didn't see it as being particularly usable outside of computing in those days because you were acting off your prompt on your computer. There's no Windows or sort of seamless methods of email clients and so on. But anyway, it showed a lot of promise at the time. Okay, and then 1993, Churn released the World Wide Web and the first web browsers became available, and that to me was the third killer application of the internet. I think that led to the actual popularisation of the internet. Up until 1993, there were very few users, generally confined to technical institutes and so on. So till 93, the internet was run by and for geeks, and primarily used for research, education and military space purposes. 1993 onwards, you've seen this change. The mass popularisation has seen businesses being very interested. So the different drivers of businesses now being involved and using the internet. The challenges began to stretch this anarchy structure, so there was transitioning from what you'd say was a total geek playground to something much more serious, and the critical nature of it as infrastructure, the technical challenges, and the legal and regulatory challenges increased massively through the 90s. During all this time, the US government had, and still to a degree has, some unilateral control over the core of the internet. But one of the moves that happened during the mid-90s was a number of people questioning the US government's ongoing role, and the US government, as a result, responded. There were a number of concepts played with, but one ended up as a green paper, then a white paper to establish a company called NewCo, which eventually came into being in 1997, 98, known as ICANN, the Internet Corporation of Assigned Names and Numbers. So it's established by the USG, but its role was to establish the policies and the framework for the management of the domain name system outside of the US government, and to be a global and globally accountable body. And in 1999, just interestingly, the ITU sort of had flirted with the internet from time to time, but became somewhat more interested as it could see how the internet was impacting or colliding or converging with the plain old telephone system. Okay, and so let's look at the alphabet soup and have a look at some of the stakeholder organisations involved in the core of the internet. Firstly, one of the critical things is IANA, the Internet Assigned Numbers Authority, or quite often called the IANA function. This is the central database at the very core of the internet, so it records the delegations of top-level domains like country codes like .nz and .us, generic top-level names like .com or .info, all of the IP address allocations, and also there's a number of other protocol issues for the technical community that are included. So this is a relatively small database, and it's published on the Internet's root servers. Now the IANA function is contracted out by the US government, and it's just renewed the contract with ICANN in the last 2 days. So ICANN has an ongoing role in administering the IANA function through to 2019. The root servers, there are 13 root servers named or numbered A to M. And there's sometimes some criticism over these root servers because 11 out of the 13 are managed by US corporations. But I think that while there are only 13 root servers, there are now myriads of mirrors of these root servers. And New Zealand has at least 2 and soon to be 4 root server mirrors. So currently one at Auckland Peering Exchange and one at the Wellington Internet Exchange. And just incidentally, the IANA database is published to the root servers through the A root, which is administered by VeriSign, who are also the operators of the .com domain name. And then all the other root servers replicate the A root. IP address allocations, IP address numbers, or IP numbers, as they're called, they're allocated by IANA through ICANN. Firstly, they're allocated to the various regional internet registries, and there's 5 of them. The one in our region, most importantly, is APNIC, based in Australia but servicing the Asia-Pacific region. And there's an MOU between those ROARs that creates the Number Resource Organisation, which steps through into ICANN through what ICANN calls the ASO, the Address Support Organisations. But also there are many countries who run their own IP address allocation modules, like Taiwan and China with TWNIC and ZNNIC, and that's where they want some level of greater control or policy over policies that are in place in their local countries, but they still have to obey the policies and provisions of the regional organisation. ISOC is another acronym, a good number of them starting with I, but ISOC is the Internet Society. It's a not-for-profit membership-based society formed in 1992, so it just had its 20th birthday, celebrated in Geneva a couple of months ago. It has something like 55,000 ordinary members. There are 130 or more organisational members, and there are 90-odd geographic chapters. And in our region, there is an Australian ISOC chapter, and there is a Pacific Island chapter of ISOC, but there isn't in New Zealand, and potentially because Internet NZ has sort of subsumed a lot of the ISOC role in terms of having this idea that the internet's for everyone. Internet NZ saying, you know, the internet should remain open and uncapturable, which is sort of another way of saying the same thing. And ISOC seeks to assure the open development, evolution and use of the internet to benefit everyone. ISOC provides the management home to the Internet Architecture Board, the Internet Engineering Steering Group, the Internet Engineering Task Force, the Internet Research Task Force, which, you know, and this is the technical playground, mainly the IETF as a public body. Anyone can belong. You can attend IETF meetings, and it's in that forum that you get to create your RFCs and create new standards or finesse standards for the internet. So while ISOC doesn't control those bodies, it provides a home and the publishing mechanisms and the organisation of the meetings and so on and so on. Also, ISOC is the home of Public Internet Registry, which is the registry for the .org top-level domain, and that provides a massive amount of funding for ISOC's broader activities and its ability to outreach and do programs everywhere. ICANN, as I mentioned earlier, the Internet Corporation of Assigned Names and Numbers, it's a Californian-based not-for-profit corporation established in 1998, and it seeks to globalise the management of the Internet's unique identifiers, or the DNS, the domain name system. It started off in life having a contract with the US government, a very clear signed contract, and it's been through a couple of iterations now, and in the last couple of years has become what's known as the affirmation of commitment. So rather than being a contract, it's more a set of statements made by ICANN about what it will do and how it will responsibly manage the core of the DNS, and the US government acknowledging that it has a right to exist as long as it fulfills its commitments. And so ICANN has two roles. One is the IANA function, which is, as I said earlier, has been recontracted to ICANN, but there's no guarantee that in the future ICANN will always have that role. And then the second primary role is to establish the policies for managing the Internet's unique identifiers. And probably the biggest thing in terms of ICANN news in recent years has been the launch of the new top-level domains program and the 1,900 applications for new top-level domains from .gay to .eco to .whatever, .kiwi and so on, all having arisen as a result. ICANN, just to demonstrate what it is, it has a board of directors comprising of constituency seats, and it has a number of what we call SOs and ACs, so support organisations and advisory committees. And you'll see at the top, probably the only important point here is that it has a government advisory committee. So it's a kind of an unusual beast. Usually governments are in charge of things. You know, in this instance, the government advisory committee provides advice through a non-voting seat on the ICANN board. While it is an advisory committee, it's a very important advisory committee because the ICANN board must take notice of their advice or give reasons back to the government advisory committee as to why it isn't taking notice of them. We'll have a look at the United Nations just briefly, created in 1948-49 after the League of Nations and World War II ended. There are 192 or 193 member states. Remembering that there are 240 country code top-level domains, so there's a lot of countries that don't have governments, or countries and territories that don't have governments. There's a myriad of associated treaty organisations, but probably spectacularly the most important in terms of the internet is the ITU, although people like UNESCO and UNDP do a fantastic job in terms of outreach and last mile connectivity, particularly in small island states and developing countries. But remember, the United Nations and its treaty organisations like ITU are government-led, and their policies are always by treaty. So, you know, treaties are kind of everybody's fifth best desire. So let's have a look at what multi-stakeholderism is. So IANA, ICANN, ISOC, the regional internet registries like APNIC were established, and Internet NZ for that matter, they're all established as multi-stakeholder organisations, so no barrier to equal participation. UN and ITU treaty organisations empower only governments as decision makers, so a really key difference in philosophy here. Multi-stakeholderism means, and I don't think there's any dictionary definition, so this is just purely mine, but it means all stakeholders from government, business, the technical community and civil society participating, and most critically on an equal basis. You know, that no one has a special place in this, that multi-stakeholderism is about equal participation. And you know, just looking through, there are a whole heap of regional organisations who invest time and effort into managing or administering the internet, and I've listed a number there. The ones in red, APEC and APEC-TEL, are marked in red, and they are not multi-stakeholder organisations. They are state-led government decision-making organisations. The rest are fully committed multi-stakeholder organisations. There's a whole bunch more. You can belong to any of these groups just by turning up or subscribing to their mailing lists. So what's happened? 1999, 2000, I think the ITU suddenly really said, you know, our plain old telephone system, the old copper loops, the days of this are numbered. This is going to disappear. And we need to be more engaged and involved, and we would like to take over the core of the internet so that we have a sustainable future. And so between 2002 2005, the UN, at the behest of ITU, ran what was known as the WSIS, the World Summit on the Information Society, a 3-year program, in which some governments were asserting that the UN take control of the core of the internet. But one of the outcomes from that WSIS process was the establishment of the Internet Governance Forum. And so in 2006, the Internet Governance Forum was launched. And this is an annual event that provides a stage for multi-stakeholder participation. So it's a non-treaty organisation. It's a there are no finite outcomes. There's no agreed text. There's no resolution at the end of these meetings, but it's a meeting where huge numbers of people go, attend, listen to others, appreciate their viewpoint, and perhaps come home and create local rules, regulations or conditions for the management of the internet at a local basis. So in summary, the internet's been a bold experiment in the development of technical policies and sometimes public policies outside of treaty organisations and governments. Technical development has been the sole criteria, with very little, if any, concern for morals, ethics, or sometimes laws. So a lot of the issues we face today is that this was about technical deployment, and the IETF and others examining things purely on the technical basis. Will this work or will it not work? And allowing users to then populate the internet and do what they like with it. And of course that leads us to all sorts of issues about the behaviours that we see on the internet today. So, and I think that, it's fair to say that the internet culture has clashed with normal regulatory institutions as it's become more popular. And the challenge remains to us today. Do we seek to control the internet through government regulation and intervention, or do you allow the technical folks the ongoing capability of rapid deployment of new technologies, and then the government's roles to tidy up and clean up, and all of us taking responsibility for making the internet safer, more secure, more stable as a result later. And one of the remarkable things that occurs to me along the way is that there's very seldom, if ever, a one-size-fits-all solution. So what might suit China with 1.2 billion people is unlikely to suit Niue with 1,000 people. Local conditions and local cultures need to determine their own rules and methodologies, and treaties don't give you that. Treaties create a binding, everybody must obey this set of rules. The internet has been the fastest growing new media in history. There's about 7 billion population, 2.x billion are connected, and just some staggering statistics like 294 billion email messages every day. Most of them arriving in my inbox, it feels like. And our challenge as internet governors, because we are all internet governors and you've all got a role to play in it, is how do we promote and protect the internet? And it's most important to remember that the internet is for everyone, ISOC's vision. You might think the Recording Industries Association might argue that the internet's for everyone except people who infringe copyright. Well, no, it really is for everyone. And so, the stage that these sorts of discussions about useful public policies and useful methodologies of cleaning and tidying the internet happen through this Internet Governance Forum. There's been 6 annual events so far. The main themes are things like access, diversity, openness, security, and critical internet resources. And the IGF is a non-decision-making multi-stakeholder participation forum where people participate on an equal basis. And there is a strong, now stronger and stronger remote participation in the IGF. So this year's event is in Baku, Azerbaijan in November, I think. But there, last year we had a number of hubs in New Zealand and the Pacific, so everyone can participate. Unfortunately, last year was in Kenya, this year in Azerbaijan, so the time zone isn't the friendliest for the time of day in New Zealand. But if you are interested in internet governance, I suggest you take a great deal of interest in the whole environment. There's been a multitude of national and sub-regional and regional IGFs evolving, particularly in the last 3 years. And next week I'm heading to Tokyo for the 3rd Asia-Pacific Regional IGF. This is New Zealand's second IGF, I think, our NetHui. There was the first Pacific IGF in Noumea April last year, and Australia is moving to have its first IGF in Canberra 11th and 12th of October this year. So you can see it's popularising as an idea and a concept, and it's really important that everyone who has a vested interest in the management, the freedom, the technical layers, or anything to do with the administration of the internet should be involved, and the best way of becoming involved is through internet governance and the internet governance forums. With that, I'll end my presentation, and my email's there. If you want some further information or where to subscribe to lists and so on, send me an email and I'll send you some links. With that, any questions?
Keith, is it possible that there be a future governance model that doesn't involve the US or the United Nations, that takes countries' governments right out of the picture?
I'm not sure. Maybe. The US government is showing no sign. Well, it's shown a certain degree of willingness to free the shackles of ICANN. Firstly, by establishing ICANN, and then secondly, by watering down the whoa, that was good. Watering down the contracts. That must be the US government listening in. By watering down the contracts and allowing ICANN to be governed by a global board of directors and so on. So you can see they're letting go, but in terms of the IANA function, which really is the core of the internet, they've actually tightened up quite significantly on the contractual obligations on ICANN. So in some ways, yes, I think they're letting go of the policy aspects, but in terms of relinquishing control of the core, it's probably got quite some time to go. And I guess the question that you should ask is, a lot of people say it's unfair or it's not appropriate that one government has unilateral control over the core of the internet. The answer is to vest it in the United Nations in 193 countries. So if one government equals bad, how can more governments equal better? It's not an equation that works for me. But I think there is an ongoing tension in that regard. There are some countries who are calling for the US to relinquish its control, and that's manifesting itself through the ITU with the WCIT, the WCIT event that's going to be held in Dubai at the end of this year where the internet and the management of the internet will be further discussed. There's a gentleman at the back.
Thanks. Chef Houston, I'd like to respond to that a little bit more about can we take governments out of this completely. And while you might talk about one government, let's just sort of broaden this and actually think about what you're doing and what you're actually asking for. The last 20 years has seen a remarkable wave of privatisation of previous public goods and spaces. It's happened in this country, it's happened in many Western democracies. Some of it's been good, some of it's been bad. When you think about the essential role of communication, do you think it's a public function or a private function? And if you think it's a private function, what are the protections for individuals and the integrity of communication if it is purely a private function? And if it's a public function and you think that there are some issues such as privacy of communication, freedom from interception, etc., and so on, how is that public interest appropriately expressed? And all of this ties into what you're talking about. Because while governments have deregulated some parts of this industry, nevertheless, most frameworks actually still say that public telecommunications is performed under the auspices, a licence to operate a facility given and granted by the government of the area as part of a necessary public function. I'm not sure it's easy to rid governments of this area, but deregulation's a strange and new world, and understanding the respective roles of governments, regulators, investors and citizens is really what this is all about. And the telephone is no rule book here. That was a different model and it doesn't apply.
Good points, Jeff. And I think, probably another way of approaching the question is to ask, has the US government done anything that hasn't been appropriate to the ongoing development and furtherment of the internet. And it's pretty... what did that have to do with the control of the core of the internet, though?
The copyright issues.
I think that's at the edge of the internet, but yeah.
They can just store the truth into people's homes?
Well, we're seeing the legal consequences of that, so it's maybe not so clear that they can storm into people's homes. Yeah. But I'm talking here about the actual core functionality of the internet, and the US government has by and large acted quite appropriately. There have been instances where they've behaved remarkably badly, but by and large their discharging of their responsibilities through ICANN and the IANA function have been very carefully controlled and managed and in the best interests of the public. And Jeff, I think there was another part to your question too that raised a bit of an alarm bell. Can I put a question to you, particularly over the ITRs? I think you're one of the few people that I know who was in Melbourne in 1988 when the ITRs, this is the International Telecommunication Regulations from the ITU, were last penned in 1988. And so this year, what's your view as to where the ITU will go with the ITRs? Will they seek to accommodate aspects of the internet into that agreement or not?
What's going on, of course, is that back in 1988, the world's governments, because at that stage most telecommunications were still largely regulated, excessively controlled, and in the same way that New Zealand Telecom was a publicly owned corporation and was basically indistinguishable from government, most countries had the same arrangement. Governments decided to further and continue the structural cross-subsidisation of rich to poor inside the telecommunications industry. And they decided that they would continue this idea that it was quite okay, if you will, to flow money from rich to poor as part of the telephone conversation. So they met and signed this wonderful idea that we'll continue to do international financial settlements because we're all basically public bodies and it's all governments. Now, that created a bunch of countries who have become dramatically dependent. At one point, the GDP of Laos, 50% of it was actually provided in cash by AT&T. AT&T was spending billions of dollars a year subsidising a whole bunch of governments all around the world, and those governments created a culture of dependence. Like Ghana, it just relied on the money. So we ripped apart the telephone system. Less than 30% of all long-distance calls are now made on the telephone system. The rest of it's Skype. And all those countries are now losers. So there is a large number of countries who see the revenues disappearing out the door and are screaming at the ITU, saying, for God's sake, stop this. You think that's weird? I just heard Telecom New Zealand yesterday look at Google and scream at them saying, you owe us money. Somehow, even though you've bought your content all the way to this country, all the way to this city, you still owe us money. So cultures of dependence are difficult, and they're very, very sticky. And the ITRs are all about that at this point. Because having pushed the investment base of the internet into private capital, a bunch of folk are now sitting in the ITU saying, private capital should now bear the burden of structural cross-subsidisation from rich to poor. And the private capital and the countries that have largely deregulated and passed their telecommunications function over to private investment, including this country, are looking at what's happening and are aghast. Because quite frankly, it's one thing to tax your own entities, but it's quite another to have an international body impose a massive tax on your private capital. And that's largely the parameters of this debate. Is anything going to happen in December? There's going to be blood on the floor, but I'm really not sure what happens after that.
Excellent, thanks. And I assume that we'll be carrying on this conversation in your session this afternoon. So if this is a session that's of interest to you all, Jeff Houston will have a look at the agenda and come along to his session, because I'm sure this will thresh out. Any further last question?
Yeah, so My question is just in regards to the IGFs. Do you see a point where they transition into decision-making mode? If so, what would be the particular topics that would drive them to that, and what would be the consequences coming into a clash with the sort of the government-driven agencies or organisations?
Yeah, that's a very good question. There have been some moves within parts of the UN to actually more formalise the IGF and make it somewhat more a decision-making forum. But every time it's been approached, there's been a rapid backpedalling. And I think currently, there are a small staff of 3 or 4 people who put together the IGF and the organisation of it. Imagine if you had to pen an outcome and go into drafting and multiple language translations and so on and so on. Suddenly it would require a whole heap of people and a lot of money. So far nobody's come up with a model that says that this could be funded in any way, and nor is I don't think there's an expressed desire from most participants to do that. I think the extreme benefit of the IGF is that you can come into a workshop room like this, discuss with, if it's Russia on the stage, their issues with child pornography or some subject, learn from them and take those lessons home and say, how does this apply in New Zealand and what lessons can we apply from this? So it's allowing you to make your rules for your country rather than, resolution by treaty. So let's hope that it never gets to resolution by treaty for internet governance, because to me that would be the worst possible outcome. Everybody's fifth choice.
Even on a local level, so say in New Zealand, you have a New Zealand-based IGF comes to a decision on some driver topic, which then puts it, in a clash with, say, the ITU.
I'd like to see the New Zealand IGF develop to the stage where government sits up and takes notice and says, these guys are onto it. It's a broad representative group that represent business and civil society and the technical community and so on. And they are clearly thinking down these lines, and we as government have been thinking down those lines. Let's see how we can coalesce and get some progress together. So I think influencing government in that way is the most that we should hope. We shouldn't be hoping that we have an absolute scripted outcome. Okay, if there's nothing else, I think lunch is ready. Thank you all very much.